let's dive right in. Today, we're tackling one of the most critical, yet honestly often misunderstood pieces of modern network security. If you've ever found yourself wondering how in the world security teams actually protect a network when almost all internet traffic is locked tight behind encryption, well, you're in exactly the right place. In this explainer, we're going to unlock the secret of firewall decryption. We'll see exactly how inspecting encrypted internet traffic is the defining factor that separates a truly secure network from a highly vulnerable one. So let's get into it. Here is our roadmap for today. We'll start with the encryption paradox, move on to visualizing the digital border, unpack trust infrastructure and PKI, explore exactly how interception works, and finally, tackle the practical challenges of decryption. Section 1, the encryption paradox. You know, the modern web presents this fascinating double-edged sword. Today, the vast majority of all internet traffic is encrypted. Protocols like HTTPS, SSL, and TLS, they've become the absolute standard. And that is fantastic for guaranteeing user privacy, data integrity, and the authenticity of our communications. For everyday users, it's a massive leap forward. But on the flip side, for network security teams, it creates a massive headache. When traffic is encrypted, it becomes basically invisible to standard inspection. Modern malware, really sophisticated attacks, and even sensitive data leaks can happen right inside those supposedly secure connections, and they just breeze right by, completely unnoticed. It is the ultimate paradox. Think of it like this. A standard firewall that doesn't actually perform decryption is essentially flying blind. It only gets surface-level information, things like the IP address, the port number, and the sheer volume of data moving back and forth. But the actual content of that communication, the payload where the real, dangerous threats hide, that remains entirely concealed. Without decryption, your security team is quite literally just guessing at what's actually happening inside your network. Section 2, the digital border. Let's ground these abstract networking concepts with a visual analogy that really makes it click. Picture a physical border crossing. Without decryption, it's basically like allowing completely closed, locked trucks to drive right across your border without a single inspection. Sure, you know where the truck came from and where it's heading, but you have zero idea what cargo is actually in the back. It could be totally harmless supplies, or it could be incredibly dangerous contraband. And this is exactly why decryption is an absolute must-have feature in next-generation firewalls, like those from Palo Alto Networks. The firewall acts as a strategic checkpoint. It transparently intercepts the encrypted traffic, decrypts it, and then deeply inspects that opened cargo using advanced tech like App ID and Content ID. It applies your security rules and then re-encrypts the traffic before sending it safely on its way. To the user, the whole thing is totally seamless, but to the security team, it brings back something fundamental: complete visibility. Section 3, trust infrastructure and PKI. So to understand how the firewall inspects the cargo, we first have to understand how those locks are actually put on the truck in the first place. When a client initiates a secure connection with a server, they do this little dance called a handshake. First, the client reaches out to connect. Second, the server responds by sending back its digital certificate, which holds its identity and its public key. Third, the client validates that certificate using PKI. Once it all checks out, step 4 kicks in. The client generates a symmetric session key, encrypts it using the server's public key, and sends it right back. From that exact moment on, all communication back and forth is efficiently and securely encrypted using that one shared symmetric key. Now, I mentioned PKI just a second ago. What exactly is that? Public key infrastructure is basically the entire framework responsible for establishing trust in the digital world. It totally relies on certificate authorities, or CAs, which are the entities that issue and sign digital certificates. It operates in a strict hierarchy. Certificates are signed by intermediate authorities, which are then validated by root CAs. This forms what we call a chain of trust. If the server certificate can be mathematically traced all the way back up to a root CA that your system already trusts, your browser gives the green light and considers the connection safe. Section 4, how interception works. Okay, so now that we know how a secure connection forms, how does a firewall safely step into the middle of it? In typical scenarios, like when employees are just browsing the general internet, the firewall obviously doesn't own the private keys for random websites, like Google or your bank. So it relies on a really clever method called SSL forward proxy. Under this model, the firewall essentially steps in to act as a secure intermediary on behalf of the client device. And here is exactly how that SSL forward proxy magic operates. The firewall safely intercepts the original connection request and actually splits it into 2 entirely distinct connections. On one side, we have Connection 1, which runs between the user's client device and the firewall, and on the other side, we have Connection 2, running between the firewall and the actual external server. By sitting right there in the middle, the firewall can transparently decrypt, inspect, and then re-encrypt the data flowing between these two halves.
Now, you might be wondering, wait, why doesn't the user's browser completely freak out when the firewall intercepts the traffic? Well, when the real external server sends its certificate, the firewall validates it. Then, the firewall actually generates a brand new dynamic certificate to present to the client. And here's the crucial part. This new certificate is signed by an internal certificate authority that is configured directly on the firewall itself. For this whole setup to work transparently, without your browser throwing up giant red warning screens, the user's devices must be configured by IT to explicitly trust the firewall's internal certificate authority. While it's playing the role of proxy, the firewall is also heavily scrutinizing the external server's original certificate. It classifies certificates as trusted or untrusted based on your specific policies. A certificate's verification status might come back as valid, expired, revoked, or unknown. And this brings up a massive security point. A certificate might be structurally valid, but it could still be revoked because it was compromised or misused somewhere along the line. To catch that, the firewall uses mechanisms like OCSP, which does real-time queries, or CRL, which checks downloaded lists of revoked certificates. Knowing this exact status is absolutely essential for making precise security decisions, like deciding whether to generate an alert, block the traffic entirely, or take some other action. Section 5, Practical Challenges of Decryption. As incredibly powerful as all of this is, we've got to talk about the real world for a second. Implementing decryption is absolutely vital, but it definitely requires some careful navigation. You're going to run into hurdles. For instance, some applications use a technique called certificate pinning, which strictly blocks any sort of middleman interception. Other apps might just break or act weird when their traffic is decrypted. You might also have legacy devices hanging around on your network that simply refuse to recognize the firewall's internal CA, which causes connection drops. And finally, the sheer process of verifying all these certificates can introduce network latency if it isn't configured efficiently. Because of these challenges, setting up decryption is definitely not a set-it-and-forget-it task. It demands continuous planning, testing, and fine-tuning by your network admins. All right, let's pull all of this together. From a professional practice and certification standpoint, understanding these core goals is just pure gold. If your goal involves gaining visibility into encrypted traffic, the core concept you're relying on is decryption. Period. When your focus is proving who a server actually says they are, that's identity validation, you are dealing with PKI, and when you explicitly need to inspect threats hiding inside everyday web traffic, the precise answer is SSL decryption. Grasping these distinctions is huge, just like understanding the difference between trusted and untrusted certificates, because they directly dictate how your security policies are going to behave in the wild. Decryption is quite literally a pillar of modern security. Without it, organizations are operating practically blind to the vast majority of their internet traffic. With it, you regain that crucial visibility, you can enforce effective controls, and you can actively defend against really advanced threats. So I want to leave you with a provocative thought to consider regarding your own network security posture today. Think back to our analogy. Are you actually inspecting the cargo, or are you just letting closed trucks freely cross your digital border? Thanks so much for joining me on this explainer, and keep learning.